So now that you know a little bit about IP version 6, let's set it up on the router. We're going to start off by assigning an IP version 6 address to our routers, enabling the protocol itself, and then going in and saying this will be the IP address or IPv6 address that we'll use. We'll then look at how the routing protocols have evolved to support IP version 6, and we'll go and do the base configuration of RIP-NG. Can you believe it? RIP made its way into the IP version 6 world. It survived. It's now called RIP Next Generation. But it still works the same. It's good old RIP. And then we're going to finally wrap things up by talking about the IP version 4 to IP version 6 migration strategies. Is there going to be a sudden cut on the internet where everybody has to switch over? We'll look at that. I'm going to use a very simple topology to demonstrate configuring IP version 6 addresses, just because this is the first time we're seeing it, and I'd like to keep the focus not so much on a large network as I am on the commands to set up IP version 6. Now, before we get into the config, let's talk about what is on this diagram right here. I've got two routers, router 1 and router 2. These happens to be the same two routers I used to demonstrate frame relay, so there is a frame relay cloud sitting in the middle of this that I just have represented as a WAN link here. Now, on the LAN of router 1, you can see this is the LAN side, I've decided to use a unique local addressing scheme. That's the private addresses in IP version 6 that all start with 1FE0. So 1FE0 is mandated. Essentially, that is what says this address is private. Just like when we address private networks in IP version 4, we say, well, it has to start with 10 or 172.16 kind of thing. Here, we have to start with 1FE0. Now, I've then designated the subnet as 1111 over here. You can see that based on my subnet mask. Remember, each one of these octets is 16 bits of information. If I were saying 172.16.0.0 and this represented the subnet, I would do a /16 because each one of these represents 8 bits of information. So same thing over here, just a bigger address. This represents my subnet, 1FE01111. So that means every client that is on this network would have to have an address that starts with 1FE0:1111, then it would be something else that would designate the client itself. Now let me just clear this off right here. You can see that I have designated, ::1 as the address. This is going to be the IP address of this interface on router 1. Now, on the WAN link, I've used one of the global scopes, 2001:10:10:1:1, and same thing over here, 210:10:1:2, with this 64-bit subnet mask. Remember, each one of these are... Oh, my mind just blanked out. 16 bits apiece. So add all those up, and that gives us the 64. The ::1 represents the host portion, and ::2 over here. So that's how I'm addressing the WAN link. And over on the right side, same thing as the left side, 1FE0 private addressing, subnet 2222. So that gives you an idea of how subnetting looks in IP version 6. Now let's set it up. I'm going to start on router 1, and on all of the routers that we use today, we have to turn on the TCP/IP version 6 protocol from global config mode. Now, in the old days, back 10 years ago, when we used routers that commonly had IPX, SPX, and so on, TCP/IP wasn't initially enabled on the router until you typed in IP routing. We used to have to type that command on all the routers, but now on the newer routers, that command's typed in there by default for us, so we don't have to type it anymore. But for IP version 6, we have to do the same thing we used to do for version 4, IPv6. And then we type in unicast routing. Because we have multicast and anycast, all of those different types, this is going to be doing unicast routing. That's like a power switch on router 1. I've turned it on. Now I can get under my interfaces. I'll go under interface fast Ethernet 0/0. And we can see that 1FE0:1111:1/32 is our address. So I'll type in IP, just like we're assigning an IP address, but it's IPv6 address. You see these similarities? Check this out. Oh, look at that. We've got link local address if we want to assign that. That's for communicating on the local subnet. Or what is the real address that we'd like to assign? Now, let me scoot this down so I can remember. I'm going to have trouble remembering these addresses when we make this move. It's going to be 1FE0 colon 1111 colon, and notice it even says you can use the double colon in this, colon 1/32. Enter. I've now assigned, a monumental moment, shed a tear. I've now assigned an IP version 6. We've made the move, starting to move into IP version 6 addressing to my router. Now I'm going to exit out of here, and let's go under the serial interface. This is still set up for frame relay, so it's actually interface serial 0/0.102. Oh, is that not it? Oh, sorry. It's 0, router 1 was 0/1/0.102. And I'm going to assign the, let me scoot up a little bit here so I can still see the address, IPv6 address 2001:10:10:1:1/64 to that interface. Oh, look at that. We've assigned the second IP version 6 address. Isn't this kind of cool? We're stepping into the future. Now I can verify show IPv6 interface. And I could even, go in here and say I want to do the brief. My show IP interface brief, show IPv6 interface brief. Looks a little different. You can see there's my fast Ethernet 0/0. It gives the link local address of that and the assigned IP address that I put in there, right, of FE80. Oh, sorry, I got that backwards. This is the link local address. You might remember FE80 designate link local. This is the MAC address, 2141C, with FFFE in the middle. If you want, you can jump back and go to the concepts again where I explain that link local address. This is the second half of the MAC address. So you can see that assigned, and then this is the one I manually assigned to the interface. Up here on the serial interface, there's the link local address for the serial interface, and there's the one I manually assigned to the serial interface. So we can see we've got IP version 6 happening now. Now let's jump down to router 2. Do the same thing. IPv6 unicast routing. Turn it on. Get under my interface fast Ethernet 0/2. Router 2 is Ethernet 0/0. IPv6 address, and that was 1FE02222. 1FE0:2222:1/32 as its subnet mask. Under interface serial, I believe it was serial 0/0.201 was the subinterface. That was it. And I'm going to assign, I'm going to need to, let's do this. Shrink this down like that. There we go. IPv6 address for that is going to be 2001:10:10:1:2/64. We now have IPv6 configured and working on our WAN link between those two routers. To test it, we can ping. Ping is still around in IPv6. We just need to go to privilege mode. You're going to get used to typing v6 on things. Ping, hit the question mark, and it says, aha, you can ping using IPv6. And it says type in the address that you'd like to ping. Well, I'm on router 2 right now, so I would like to ping 2001:210:10:1. It's not as fun to type these, though, I'll tell you that. ::1, and hit the enter key. Check it out. We've got pings on IP version 6 going through our frame relay cloud, and I was able to ping router 1. Let's do the same thing. I'll do ping IPv6. See if I can get to 1FE0:1111:1. And I'm not getting there. And the reason why, as you very well know by this point, is because router 2 doesn't know about that network because it's not directly connected, and we need a routing protocol. Now in IP version 6, we can do static routes, global config mode, IPv6 route instead of IP route to enter those in. But nearly every routing protocol that exists has also been updated to support IPv6. RIP next generation is what we're going to configure in here, but they also have OSPF version 3, that's the next version, EIGRP and ISIS for IP version 6, those have been modified, and BGP, which is the routing protocol of the internet, has now become multi-protocol BGP, which supports not only IPv4 addressing, but IPv6 addressing as well. So with that, let me show you how to configure RIP next generation for our network so we can get some routing tables going on. I'm going to bring us back up. I've got router 2 right here. And if I wanted to start the RIP process, I need to go into global config mode, and instead of router RIP, I type in IPv6 router, RIP, followed by a tag. Now this is just a string identifying the process. It's anything that you want. You can put a name, you could put a number, you could put anything there. It just identifies the RIP process. I'll just put 1 as my tag. But I'll need to remember that tag because we'll need it when we start turning on the networks. Oh, and I haven't told you yet. That's all you have to do under the router process. The network statement is gone. Hallelujah! This is great because the network statement has always been the most difficult thing for me to teach. I'm completely selfish on this because it boggles everybody's mind when they're thinking, okay, you use the network command to turn on RIP for the interfaces? What? What do you mean? So you type network and it has to identify the interfaces that way? That's weird, and it takes people a little while to catch on to the network statement that turns on RIP. Now they've done what's logical. If you want to turn on RIP for an interface, all you got to do is go under the interface. On router 2, interface Ethernet 0/0. That's the one connecting to the LAN over here. And you turn on that interface for RIP. I would say IPv6 RIP. You type in what tag, 1, and then you type in enable. Enter. That now turns on RIP for this interface, and it's sending out hellos, or not hellos, but broadcast, multicast traffic out that interface to say, hello everybody, I know about this network, and it's advertising this network in its advertisement. So I need to go under my interface serial 0/0.201, my frame relay interface, and also type in IPv6 RIP 1 enable. I go under the interfaces that I want to turn RIP on, and just type in enable underneath there. Now let's go on router 1 and go into global config mode, IPv6 router RIP, and give it a tag, and I'll stick with 1. That's all we need to do to turn it on. I go underneath my interfaces. Router 1 has fast Ethernet 0/0, and type in IPv6 RIP 1 enable. Turn on RIP for that interface, and interface serial 0/10.102, which is my sub-interface connecting to router 2 over frame relay. Hit the up arrow, and I'm good. I now have RIP fully enabled on router 1 and router 2. Now, before I do the exciting ping attempt to router 2's LAN interface, I wanted to show some of the verification commands. I can type in show IPv6 RIP to see the process and see what's going on. It shows RIP process 1. It's part of this multicast group because remember, you don't send broadcast in IP version 6. You do multicast. So this will be kind of its broadcast address it's sending to. Administrative distance is still the same. That's its believability. Updates once every 30 seconds, and it's working for these two interfaces. I'm going to type in, remember the show IP RIP, or sorry, show IP route command. I'm going to type in show IPv6 route to see the IP version 6 routing table. And you can see that we have all of these routes that are being sent. We've got the keys up here, the connected interface. This is link local, connected, connected. I'm pondering here because I'm not seeing my my RIP route from the router 2. That's not good. Hang on, let's look on router 2. Show IPv6 route. Oh, wait a sec. It's got it there. Well, let's hang on router 2 for a second because I've got one working. We've got router 2 right here that has learned about via RIP 1FE01111. You see that right here? It learned about that from router 1, administrative distance of 120, 2 hops to get there. So, and it says via this is the next hop address. It's a link local address on serial 0/0.201. That's the frame relay link. Hang on, let me just go back up to router 1. Show IPv6 route. Interesting. I wonder why router 1 isn't learning that. Let me verify my config on router 2. Let's do show run interface Ethernet 0/0. Oh. Ladies and gentlemen, the interface is shut down. Easy fix. I'm going to go under Ethernet 0/0 and do a no shutdown. And now we should have that interface come back online. There we go. And now let me jump back up to router 1, show IPv6 route. There it is. That's it. The RIP route, 1FE02222, which is the route sitting behind router 2 over here. Now let's do a ping. We've got a ping. Ping IPv6 1FE0:2222::1. That's the LAN interface of router 2. There it is. We have a successful ping. Let's try a trace route, IPv6. And I'm sure with these addresses, I'll be used to cutting and pasting. Copy, paste. Wasn't very exciting, but one hop to get there, right? We went through router 2, 2001:210.10.1:2, router 2, and then it was able to reach that address. So you can see all these commands have been modified to support IPv6. The last thing I'd like to talk about in IP version 6 is the migration strategy. How does one migrate to IPv6? Well, technology exists right now to provide a smooth, non-pressured transition, meaning the Internet is slowly moving over to the Internet version 2. Companies are going to upgrade to IP version 6, but the developers of this protocol and the developers of the Internet too didn't want this to be like a Y2K sort of crisis, where all of a sudden on this date we're going to be making the big cutover, and if you don't meet the standards by this date, you're cut off. You can't access the Internet anymore. It's going to be a smooth, non-pressured. The way that we can do it, there's 3 different strategies. Number 1 is by using dual stack routers. What we can do is go in here and set up a router that runs both protocols at the same time, IP version 4 and IP version 6. The router can have, and the IP version 4 Internet will be around for quite some time to come. The router can have one link over there and one link to the IP version 6 Internet or Internet 2. And as we slowly migrate our clients, one by one, we have IP version 4 clients. They can keep using the IP version 4 Internet, and IP version 6 clients will be able to use the new version 6 Internet. And we can slowly, in phases, migrate our clients over. Now, you might be wondering, well, will there be like this great divide on the Internet where like half the sites are on the version 4 and half the sites are on version 6? The answer is no, because the Internet service providers are going to be doing translations for us, meaning ISPs will offer connections to both, and if you're a version 4 client and you are on a version 4 Internet through the ISP, and all of a sudden you access a site that's only available on the version 6, there will be a system of NAT, which we'll talk about in just a moment, that will allow you to go through a router and get NATed out to the version 6 Internet. And likewise, if you're a version 6 client out here and you need to access a website that's only available on version 4, you will kind of NAT through or translate through to the version 4 website and communicate with that and be able to reach that information. Likewise, the websites and powers that be on the websites themselves will have websites that are assigned version 4 and version 6 addresses so that, whoops, this is a 4, version 4 and version 6 addresses so that they are accessible from both networks. So that's the first system is to have dual stack routers. The second one is going to be doing tunneling, meaning maybe you've got a version 6 internet that you're connecting to, and your internal networks over here are still only running version 4. Well, you can create a type of tunnel, which is kind of like a VPN, through the version 6 internet. Oh, let me just get my drawings right here. Through the version 6 internet that allows the version 4 protocol to work through there and communicate between these two version 4 networks. That will allow you, even after the internet has moved to version 6, it will allow you to have your network still using version 4. And likewise, maybe the internet hasn't moved to version 6 yet. We're still using a version 4 internet. Well, you could tunnel your version 6 networks, if you've migrated your networks over to version 6, through the version 4 internet, this is version 4, and allow you to run version 6 on your networks and tunnel through the existing internet. That is what a lot of agencies are doing overseas that have begun the migration to version 6. Places like Japan and China have a huge step forward in version 6 over the United States. They're running version 6 right now and tunneling through the version 4 internet for most of their networks. Last but not least is NATPT. NATPT stands for NAT Protocol Translation. This is a specially tweaked version of NAT that can go between version 4 and version 6 protocols. So if I'm running IP version 6 on my internal network and connecting to the version 4 internet, I can NAT between those two and allow my version 6 clients to surf the web over here. Likewise, if I have, version 4 over here, and I have not upgraded to version 6, and the whole internet changes over, and only a version 6 internet is left, I can NAT between my version 4 IPv4 network and IPv6 and not really suffer any major disadvantages. Static NAT will work, NAT overload will work. It's just like, NAT as we know it. So the cool news is yes, the internet too is out there. It's been out there for years. And it's slowly overtaking the world like a virus, piece by piece, network by network. The internet too is growing larger and larger. And the internet that we know today, the internet version 4, is shrinking smaller and smaller and smaller. I guess technically that's not true. It's always growing, but it will eventually shrink smaller and smaller until all that's left is the internet 2 or IP version 6 internet. At that point, NAT, once again, comes to save the day, allowing us to run either version of the protocol on either network. That should give you a really good idea of IP version 6, what it is, and where we're going with it. So let's review. We talked about assigning IPv6 addresses to your router. Very similar to IPv4, we just type in IPv6 and followed up with that address and what our address is. It's getting used to those addresses that's what's going to take the time. We looked at the new routing protocols, seeing that every routing protocol has been updated to work with IP version 6, including RIP version, I was going to say version 6, RIP NG, next generation. And we even went through and set up the base configuration of RIP to exchange IPv6 routes on our network. Finally, we just looked at all the IPv4 to version 6 migration strategies. Non-pressured is the key. People will be able to move to IP version 6